it's time to take a look at data frames in terms of an overview. We're going to load the data, do some brief statistical analysis of the data, and just then make a decision on the data as to whether it may or may not work for a student project. Ultimately, it's up to you whether you want to choose a data set for a project, but the steps that we take today are the steps I want you all to take to help you make that determination. So here's what we're going to start with. Let's go to my GitHub page. Well, Google suggesting search Corey Wade GitHub, which I did before. So it's github.com/Corey J. Wade. And if you click on repositories, you will see BCA datasets. Okay. So I want to pick books updated. Actually, fixed books. Not sure about the difference between those. Let's try fixed books. And remember, to actually view a GitHub file in a data frame, you need to actually hit view raw. Okay, and you can see it's a lot of book info. Go ahead and hit Command C. Copy it, and then open up your new Colab notebook, colab.research.google.com. Click on a new notebook link, and go ahead and assign this to the URL in quotation marks. All right, now, can you go ahead and load this data and look at it? I want to give you a chance to do it on your own. Okay, go for it. I won't stay here for too long in case you need help. I'm going to jump in. So recall that the steps are import pandas as PD. And then if you're unsure about the next one, by the way, you can, if you remember that it starts it starts actually, see, you always want to import pandas first. Then you want to turn it into a data frame. Think about it like that. And we call it DF. So you want to get a DF as your variable doing something with pandas. That's why I load it. So PD dot, and then the key is to remember read. So read underscore CSV. You get used to it quickly. URL in parentheses. Then to show it, remember what that is? DF dot head. Shift enter to run all that. Let's see what we get. Okay. We've got some books here. It's like a lot of Harry Potter. I remember when Harry Potter was all the rage. We have book ratings, the authors. Now let's go over some things, right? This is comprehensible, right? We understand what the columns mean here. Maybe you don't understand ISBN, but ISBN is actually books are identified by their ISBN uniquely. Gives us the language, number of pages, the ratings count, kind of interesting. The text reviews count, publication date. Okay, so we got some different stuff here. Now, let's use the following methods. Okay, df.info. You're going to use these for every data set that you consider. And I would also consider doing them in this order, because you may decide, oh, this wasn't what I thought it was. Well, you don't need to continue with df.info. If you decide you want a different data set, move along, okay? If you decide, you know what, I'm considering this one, try df.info. Press shift enter, let's see what we get. Okay, so here's what I want you to look at when you're looking at these. Number one is the non-null. When these all match, good. That means there are no null values. It's a clean data set. That's good. What else? You can look at the data type, like how many objects or strings. That's a lot here, I don't know. It's a lot of strings. There are some numeric columns, 1, 2, 3, 4, 5, 6, so I think it's possible. But some of those, well, we don't need to analyze the numeric columns here, okay? Again, if you decide, oh my gosh, this is too many null values, too many string columns, I'm done. If you want to go further and say, you know what, but I really like books, maybe there's a way with the numeric columns. Next step you want to take is df.describe. Okay? It's parentheses, it's a method, then shift enter. Now this is kind of cool. So what pandas does is it only shows you the numeric columns. Now we're going to analyze these, okay? Book ID number. Meaningless. Why? It's because they're unique and they don't really tell you anything about the book. You know what I mean? Like, we're better off looking at the titles, but in the world of data, we want to store it by numbers, okay? Average rating. Now that's interesting. What's the rating? So let's look at some of this now. Look at the mean. The mean is a 3.9. You guys know this, right? You go online and you look, everything's like 4 is average. That's probably out of 5. The minimum is a 0. The maximum is a 5. And then look at this. I want you to compare the median to the mean. The median is 3.96 and the mean is 3.93. Very close, very symmetric in the ratings. Okay, so that's interesting. What else do we have? ISBN, again, that's an identifier. ISBN 13, I guess. You know, it's a numeric identifier. Number of pages is interesting, right? You can look at the mean is 336. Okay. Look at the max, 6,576. Can you imagine reading that one? What is that? And note that the median here is 299. So what happens, you see how the mean is more than the median? That extreme value, those big books like the 6,576, they're pulling the mean away from the median, okay? They're skewing the data. The ratings count, I guess it's how many people rate the books. Is that right? Well, look at the mean. It's so what this E plus 0.4 means is that you add 4 decimal places to it. So it's not 1.7. It's 17 would be E to the 1, 2, 3, 4. So you're basically looking at these. 17,936. Oh. Well, look at the max. That's the issue. And if you look at the median, see the median is just 745. So this is a case where you have what I would call extremely skewed data. How do I know it's extremely skewed? From 2 things only. Comparing the mean to the median. Okay? It's just a magnitude of 2 magnitudes of difference. Where it's 745 versus 17,000. But you see why? Because you have extreme values like 6 of these, that's like 4 million, right? 1, 2, 3, 4, 5, 6. Yeah, 4 million. Okay. And this is what happens typically with ratings where you have, you know, very few books that are extremely popular, like the Harry Potters and stuff, and they really skew the data. The text reviews count is likely similar. So that's all we're going to do to determine if, you know, something is or is not worth considering for your project. I think for you, you know, some of the things I mentioned, right? Is there a column that would make sense to predict from the others? Well, I mean, you could try, like you could try to predict the rating, and you don't only have the numeric columns to go on. You have the ratings count, the text reviews count. And if you go back up to the data, it's not that you can't use text columns. You totally can. You could use the author, okay, to help predict. I think the title should be unique. Sure, if there's a series like Harry Potter, you know, you could consider the title too. But usually when you're looking at text columns, which we'll talk more about another time, you want ones that are actually going to be repeated, right? So you see, oh, well, hey, J.K. Rowling's other 5 books got good ratings, so this one probably will too. Whereas if like you're taking another author, it's not a series, some new title, you can have less information on that. And publisher, right? Certain publishers may have higher rankings. So I will give you my official determination. I think this is possible for a machine learning project. I think it's not ideal. I think if you love books and this is the best book data set you could find, I think you can make it work. Might be a little challenging and interesting to get some of the text columns to work, but it could. It's not something that I would personally choose though as a good machine learning project. Okay. So let's take a look at another one. I'm going to go back to the BCA datasets online and go back here. Let's look at, here's a topic that I find interesting. California fire incidents, especially because we've had like the worst fires coming up. And we'll try to look at some contemporary data sets. I'm not sure how far back this one goes. Let's find out. Okay, so you click on it. And then click on raw. And here we have it. Click on the URL. Go back to your notebook. And now something you can do, by the way, if you're like, well, if you double click, first paste this in as URL. Now, if you want, you can go up and like copy these, because like if you always do that, it's going to load. Copy and paste means you can write a function to do it, right? I'm not going to do that now because I don't want to overburden people. But we're redefining URL now as this fire one. So here we go. What do we got? Acres burned. That would be the thing to predict. Let's see what we have here. Active, if it's still going on. Likely it's not because it's in the past. Some admin unit, air tankers, the year, URL, county IDs, a lot of null values. A lot of info here. Percent contained. You'd hope they're all done in 100% contained. So there's a lot of columns here. But I can tell you, I'm going to discard this one right now. Because there, as you can see, it's loaded. NaN means null values. It's loaded with null values, so that's a strike. Also, hardly has any numeric columns. And look at when they start. Yes, you can turn that into one. But this idea would be, if you want to predict the number of acres burned, what are you going to use to predict that? You would have the year. And, it seems like when you're looking at making predictions, you want to use like the data that's going to be available, not the data that's going to be there after the fact, like air tankers and stuff. So I don't think this one is right for machine learning. Okay. Let's move on. Try another one.